how it works has been developed over many years. Let us step back in time and see how our understanding has changed over the ages in this icon history of light. Back in 450 BC, Empedocles, an ancient Greek philosopher, believed that there were four elements: earth, water, air, and fire. He believed that the eye was made up of fire and was the source of light. He also believed, correctly, that light must take time to travel. In 300 BC, Euclid of Alexandria, a Greek mathematician, believed that light travelled in straight lines, known as rays. He used ray theory to mathematically explain reflections. He also questioned if the eye was the source of light, if one could see the stars immediately when the eyes were opened. In 1000 AD, Al-Haytham showed that the eye did not emit light but received it. He used a pinhole camera as evidence. For further proof, he observed that it is painful, in fact harmful, to look at the sun, showing that the eye is not capable of handling such light. Instead, he believed that objects reflect light and that light is what we see. Light, he believed, was constructed of many tiny particles travelling in straight lines. Using ray theory, he experimented with lenses, mirrors, and refraction. Moving on to 1270, Francis Bacon published a book which became the standard on optics concerning mirrors and refraction. In 1590, Zacharias Janssen applied the theory to make a compound lens microscope. In 1604, Johannes Kepler used his skill in mathematics to show the inverse rule concerning light intensity over distance. He understood how the eye works, particularly concerning how the lens converts the image and focuses it on the retina. Because of this, he understood long and short-sightedness. He believed, also, that light had no matter, weight or resistance and travelled with infinite speed. In 1609, Galileo improved the telescope design and was the first to use it for astronomy. In 1632, René Descartes is best known for his contribution to Snell's law concerning reflection and refraction. Although others had discovered this law previously, he was the first to publish it. In 1665, the mathematician James Gregory was the first to observe diffraction by using a feather as a diffraction grating. 2 years later, in 1667, Ole Rømer calculated the speed of light by observing the moons from Jupiter, although the value he got was about 26% lower than the true value. In 1704, Sir Isaac Newton published his book on the theories of light and colour. He believed very strongly that light was made up of particles in spite of the opposition he faced. He showed that white light is made up of colours, and that colours were not a corruption of light. He also built a reflecting telescope to avoid a coronal aberration. In 1746, Leonhard Euler in his publication believed that the wave theory provided a far easier explanation for diffraction. A breakthrough occurred when in 1807 Thomas Young performed the double-slit experiment. It provided conclusive evidence the light was a wave. He also performed extensive research on vision. In 1846, Michael Faraday is best known for showing that there is a direct relationship between electricity and magnetism. 4 years later, in 1850, Léon Foucault accurately calculated the speed of light through air and water. In 1864, James Clerk Maxwell took Faraday's experiments and made the link between electricity, magnetism and light with electromagnetic radiation. He proposed that light waves were able to travel through a vacuum, as they were made up of electronic and magnetic waves perpendicular to each other, and one being the other's medium. He also presented the first durable colour photograph. It has been said that he completed the classical theory of light. In 1887, Heinrich Hertz found experimental evidence of electromagnetic radiation while investigating radio waves. He also observed the photoelectric effect, noting how certain types of light induced a flow of electrons. In 1900, Max Planck postulated that electromagnetic energy is quantized. While it supported his research and mathematics, he felt that his results were incomplete as it contradicted the wave theory of light. In 1905, Albert Einstein published his theory of special relativity, in which He said that the speed of light appears constant to an observer. He also explained the anomalies observed with the photoelectric effect by using a particle theory of light. In 1916, Robert Andrew Macmillan performed accurate experiments to contradict Einstein's interpretation. However, the results supported them. In 1925, Louis de Broglie proposed that all matter has properties of particles and waves. He even calculated the theoretical wavelengths of electrons. His theory was proven correct in 1927 when Davisson and Germer performed an experiment which showed the wave behaviour of electrons by diffracting them through a crystal. The theory of light has developed quite a lot over the years. If you want to see one aspect of light be elaborated further, leave your suggestions in the comments below. Until next time, thanks for watching and goodbye.